All right, guys, so today we are going to be going over the power rule and then also how to use our calculator to find the derivative. So as it always goes in math, right, you do all the hard stuff first, and then your teacher says, oh, but wait, here's a fun trick that makes it a lot faster. So it's kind of what we're going to be going over and talking about today. My trial, I'm waiting my product key to get my calculator back running on my computer. So we will go over this in class on Tuesday. But if you want to practice some of this over the weekend, here are the following steps for estimating that derivative or that instantaneous rate of change at any point. So you would go to math, click the math key on your button and scroll down all the way to 8. And then you're going to enter dx because you're finding the derivative with respect to x, plug in the function, and then enter the value that we are evaluating at. So that's essentially saying like f prime of -3 is -11. We're going to move straight to the power rule today. And what the power rule does, it's a faster way of determining the derivative equation. So to get the derivative at an exact point, we would find the equation first, then plug it in. But what the power rule says is the derivative of any function raised to the nth power, right? All we do is that exponent jumps down and becomes the coefficient and then reduces by 1. So it's easier to work through this than it is for you to look at that notation. It'll make way more sense in a second. So use the power rule to find the derivatives of the following. So I'm going to say y prime equals, because I'm derivating, this 2 comes down and becomes a coefficient, and then I'm going to reduce that by a 1 or subtract 1, so 2x to the 1, or just 2x. What this means is I could then take this, here's my general equation for the derivative. I could then take this and find that instantaneous rate of change at any point on that x squared, and it would be represented by the equation 2x. So for example, if I wanted y prime of 4, that would be 2 times 4, which would be 8. Or I know that the rate of change happening at positive 4 on x squared is going to be up 8 over 1. For part B, let's say f prime of x equals, same thing, so that 4 becomes the coefficient, x, and then you're going to reduce that degree. So our derivative is 4x cubed. Make sure you're using notation to show that that is a derivative, that prime. I'm going to rewrite this guy first to make it exponential on part C. Y equals x to the 1/2. So now when I redo this, I'm going to say, all right, I know that y prime equals, that 1/2 becomes a coefficient, and then we have x to the -1/2. Remember, we don't ever like to have negative x values, so what I'm going to do is I'm going to move this x to the -1/2 to the denominator and make it the square root of x. So I'm going to rewrite and say y prime equals 1 over 2 square roots of x. Because when that goes to the denominator, that exponent becomes positive, and I know that 1/2 is the same thing as square root. So you could also leave it like that. Either way works. Let's look at D. Again, we're going to rewrite, and I'm going to say g of x. We always want to rewrite so that we have exponents. I'm going to say this is x to the -1. So same thing here. G prime of x equals, that -1 becomes the coefficient, and then I subtract 1 from the exponent, so that becomes x to the -2. We're going to rewrite to make sure that those exponents are positive. So I have g prime of x equals -1 over x squared. Rewrite x to the -2. F prime of x equals -2x to the -3, or f prime of x equals -2 over x cubed. Last one here. I'm going to rewrite this as x to the -2/3. Same thing, this comes y prime equals -2/3 x to the, oh boy, I need to subtract, so if I do -3 over 3, -5/3, And then what we're going to do is rewrite that for that positive exponent, and I'm going to say y prime equals negative 2 over 3x to the 5/3. And guys, it is as simple as that. Whenever we have a coefficient, it stays the same. We're just going to keep on applying. We're just going to be multiplying that in by whatever was previously there. So what this becomes, y prime equals, this 2 gets multiplied by that 3. So this is going to be 6x. Reduce that exponent by 1. I'm going to do one more. I'll do 2 more for you guys. Let's look at D and F, and then I'll ask you guys to pause and do the rest on your own, and then check it at the end of the video. So I'm going to make this 3x to the negative 2, so very similar to A. G prime of x is going to equal negative 6x to the negative 3. And I get g prime of x equals negative 6 over x cubed. Let's look at F because he looks a little tricky. I'm going to rewrite this as negative 8x to the negative 4/3. So same thing, that negative 4/3 gets multiplied by that negative 8. So I say y prime equals, that's going to be 32/3. Negative times a negative is positive. This is going to be x to the, remember we need to subtract 1, so I'm going to be minus 3 over 3. And then when I do that, I get a negative 7/3. So when I rewrite that with positive exponents, I get y prime equals 32 over 3, x to the 7/3. Please press pause and then check the rest of these guys when you're finished. All right, guys, please check your work here. Hopefully you're feeling confident about this rule. We will get a little bit more practice in on Tuesday and then start moving on to some more derivative rules. I will see you guys on Tuesday. Have a wonderful weekend.